In this video, we're going to look at solving trigonometric equations involving identities. And again, if you've looked at a couple of the other examples, these are the identities that you really need to know. So we're going to look at this example here. Sine of 2 theta is equal to sine of theta. Now here, we have the same trig function. That's usually something we want. But we have a double angle here and a single angle here. So you can't just mix the two. You can't divide by 2. You can't do any of that. And if you don't believe me, you can just plug some values in for theta and see if it works, whatever you decide to do at the, like if you try to divide by 2, or I don't know what you might do. Just pick a value of theta, a few values of theta, and see if what you are getting is a true statement. Okay? So let's look at the identities we have available. And it looks like sine of 2 theta, the only choice we have is 2 sine theta cosine theta. So we're going to use that. So here we go. Instead of working with sine of 2 theta, I'm going to work with 2 sine theta cosine theta. And I actually do prefer this because at least I have a single angle and there's a sine theta. Now, although we have more than one trig function, at least what we can do is move everything to one side and then factor. So 2 sine theta cosine theta minus sine theta, so I'm bringing this sine theta over, equals 0. And now I can factor and say, okay, what's common to both of these terms is the sine theta, so I'm going to factor it out. And I'll be left with 2 cosine theta minus 1. Right? And again, this is from the theory. I have a product A times B equals 0. If I have a product equal to 0, one of the factors must be 0. So I can say either sine of theta is 0, or 2 cosine theta minus 1 is 0. And now here, let me go ahead and finish. We've already solved for this. Your knowledge of the unit circle can tell you that. So here, cosine theta is equal to 1/2. All right, so here I'm looking for what angle is the y-coordinate a length of 0. Right? In your knowledge of the unit circle, y is 0 here and here. So that's 0, pi, 2 pi, etc., 3 pi, on and on and on. So technically, if I'm in the reals, for example, then I would say I could pick any solution. I could pick pi and say plus k pi, because the distance between any two solutions, so if this is a solution, the next solution is pi away. And if this is a solution, the next solution is what? Pi away. So these are equidistant, right? And therefore I can capture all of them by picking a solution, say for example 0, and then adding multiples of pi. So you don't really need the 0, you could just say k pi. And that'll handle this. Now let's look at this one. Where, for what angle is the x-coordinate a length of 1/2? So you look at your unit circle and you say, where is it that I'm only going in the x direction about 1/2? And it's positive. So it looks like about here, right? That would be pi over 3. And where else though? Well, we have one over here, 5 pi over 3. Right? There's your reference triangle. So both of these are solutions. However, these are not equidistant. So what I mean by that is the distance from here to here. So if I start, for example, at this solution and go to this one, or it doesn't matter, this one to this one, it's a short distance. So if I start here, for example, and I travel a certain distance to here, my next solution, now the next time I go from this solution back to here, this distance is what? Much bigger. You can see that visually. So there's no way I can start at one solution and capture all the other solutions. So I have to handle them separately, and I have to say pi over 3 plus 2k pi, and then 5 pi over 3 plus 2k pi. Okay? So you have to handle those separately. All right, that takes care of all that. Thanks so much for listening.